Hello and welcome. We are looking at the last week in Algebra 3-4. We're looking at from the April 21st, that was a Tuesday, to April 24th on a Friday. We tested on Monday, April 20th, I do believe, from the last chapter. This is your last chapter, and looking at this last week, there's not much to cover. I will go through some example problems. We started with standard equation of a circle. We looked back at completing the square. Doing things like that in order to graph a circle. I'll go back to that. Then a little more on circles, making sure you had it all. And we revisited parabolas. We looked back at standard equation, vertex equation, word problems, vertex. Not too much on intercepts, but we won't do too much on intercepts right now. We're looking at the focus and directrix of a parabola. These weird kind of little things that are in a parabola. All this stuff is based on what are called conic sections. So let's look at that next. Conic sections are the curves obtained by slicing a 3D cone from a 2D plane. So imagine if you had two cones stacked on top of one another. There are four specific types of slices that you could obtain as you do conic sections. And the two that we've done so far are the parabola and the circle. Now keep in mind, a circle is only a specific form of what's called an ellipse. You might know it better as an oval. Imagine if, here, I can probably actually do the shape. Imagine if this is your circle here with a radius. There's something else called an ellipse that's basically a stretched out form of that. So circle versus ellipse. A circle is a very specific form of ellipse. So whenever we refer to conic sections, the three really unique types are the parabola, the ellipse, and the hyperbola. Now, as you can see, the circle is when you cut a plane straight through one of your cones here, and it forms that perfect looking circle. Obviously, we're looking in 3D form, but imagine this is a circle right here for the cone, then this is also a circle. The parabola is if you angle your plane a little bit and you cut all the way down so that it doesn't hit any other part of the cone, there reveals a parabola. An ellipse is if you cut it at such an angle where it hits two sections of your cone, such as here and here. It's like a skewed circle, like I said. And the hyperbola is where you cut it in such a way that it not only creates a parabola on one end, but on the other end you also create a parabola as well. These are the four unique types of shapes that you can make out of slicing a 3D cone from a 2D plane. Now people might ask why. Like, why do we do this? Whatever else. Like, what's studied with this? Well, for one, there's that thing that was called the focus, or ellipse also has something called foci, same with hyperbola. Plural of focus. But also, as I go through, I did some digging and some research here. Here are some real-life applications and occurrences of conic sections. So you'll see the different sort of conic sections being utilized here. A lot are parabolic. Okay, and then obviously if you have two of them, then it's considered hyperbolic as we go through and through. And you can press pause and take a look at these. Notice none of them say circles. That's because if it is an ellipse, you can refer to that as a circle as well. So those are how conic sections are used in real life. And I'll just move straight on through. Okay, so the circle, so this will stay on top when I do circle section things. These are examples that we've had out of our packet, so when they look all skewed, that's because it's from a scanned sheet of paper. So I'm just going to go ahead and use those as I go ahead and make my graphs and my other stuff here. So the circle is the locus of points that are equidistant from a single point. One other great thing about conic sections is they can be described by the location of their points. So locus is like a set of points arranged in a certain way where you reveal their location. I think in class I said set. I wanted to really say location. So that you're saying, okay, that's describing where the points are. They are all equidistant from a single point. So if this is my circle here, this rim, this set of points, there is a center point, and I can draw a radius r to any direction, and I will get any point on my circle. And that's what creates the circle. So let's say on a graph you had a center point called HK here. I can pick any point x sub p and y sub p, or whatever. X sub p is the distance away from 0 in the x direction. Y sub p is the distance from y, or from 0 in the y direction here. H is the distance from is the distance from 0 in the x direction. K is the distance from 0 in the y direction. So if I'm looking at all this information right here, let's see, this distance then right here, if I want to consider this y minus k, if I consider y to be the forefront guy right here, and this distance would be called x minus k. And this is r, this distance right here, this is your radius. So your circle equation is then derived by this. Basically, this is Pythagorean theorem. A squared plus b squared equals c squared. As you see, a right triangle has been formed for these distances right here. I've created a right triangle, and as you can see the equation of a circle, you can find the radius by having any point on a circle, x and y, and the center, h and k, and any point can be revealed. The radius can be revealed using any of that information right there. And of course the center is at point hk. Okay, so let's do some examples. I do believe that these examples asked us to find out what the center was, what the radius was, and graph. Okay, so we'll do those. So here was an example on your paper here. So if this was an x minus h plus y minus k form, let me rewrite that one more time. This is x minus 4 squared plus y squared is really y minus 0 squared. And 64 is also known as 8 squared. So this might help you be able to find out that your center is at the point 4, 0, and your radius, that's 0, and your radius, therefore, would be 8. Now as a graph, I'll do a super quick one for these things here. Okay, as a graph here, your center is at 4, 0, right there. And if you're going to do the radius, I'm not going to do this all the way around, but imagine your radius was 8 here. I would have to go here. Well, you know what? Yeah, I will do this. 1, 2, 3, 4. I'll make my center 4, 0 right there. If I want to make a radius of 8, I should go 8 in the directions of north, south, east, and west. 3, 4, 5, 6, 7, 8. Here's one of my points as I go out on my radius here. 1, 2, 3, 4, 5, 6, 7, 8. Whoops, not right there. 8 was up there. Here's another point I can do. These aren't perfectly scaled. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. Obviously not very well scaled. But anyway, if you did do a circle through here, I'll rough as best as I can a circle through these guys as I draw this. My circle will basically hit all of those points because that's a radius. Let me unfill that. Let's try that again. There we go. So if I scaled this right, then the circle would hit all 4 of those points right there with a radius of 8. It looks like it hits those 3 pretty well. That one's a little off. So there's my graph right there. There's my circle. This one here, we have to make sure that we get it in that form of that x minus h, y minus k business right here. So the only way to do that is if I complete the square here. If I join up any x-like terms, any y-like terms, and my constant flips over on this side, I can complete the square with these guys and I'll be good to go. So here I have x squared plus 4x. To complete the square, I'm going to add 4. That's going to be divide this term by 2 and then square it, and I get 4. My next term here, or my next set, if I have y squared minus 10y, divide negative 10 by 2, that's negative 5. Square that number, you get 25. Now as I subtracted 13 over, I also have to add what I added over here. You can't just add values without keeping your equation balanced. You must have balance in your equation as you go. So now I've made a perfect square trinomial. This allows me to write this as x plus 2 quantity squared. This guy right here is going to be y minus 5 quantity squared. And negative 13 plus 4 is negative 9. Negative 9 plus 25 is 16. So this then has become my proper form for my circle. Now remember, 16 is r squared, so I could have also written this as 4 squared. So this, my center, then becomes, this is x minus negative 2, so this is negative 2 here, and my that k value is 5, and my radius is 4. So there's the information that I need. And as I graph this, center at negative 2, 5. Right there. If I have a radius of 4, I'm going to go 4 in every direction. Let's go 1, 2, 3, 4. 1, 2, 3, 4. Every direction, north, south, east, and west, I mean. So about right there, and that's going to be the look of my circle. So as I go ahead and circle that up, it looks about like that. And that one hit a little bit better scale. And there's my circle. So looking good. Okay. Moving on over. Let's go ahead and find the equation of this circle. If you have the center at 3, 6, that's your h and k value. And you have a point on there, 1, -1. So that's an x, y value right there. That's any point on this circle. For instance, this circle, let's say that this number for h was, let's say this was 10, and let's say this number here was 7. So your center's at 10, 7. And let's say this point right here was, I don't know, 12 and 3. Right? There's a point on your circle that's 12, 3. There's also a point on your circle up here. Let's say this point was 12. I guess that would then have to be 11. 12, 11. And then maybe there's another point over here. All of these are different x, y values, but the thing is, no matter which x, y value you substitute into your equation, when you do this, you should still get the same radius. So what we're going to do is we have all the information x, h, y, and k. We need to figure out what the radius of the circle is. We're just going to use one of our points, 1, -1. So imagine this circle looks like, here's 3, 6. Boom, right there, there's your center. And then there's a point 1, -1 right there. So your circle, if I rough this out, our circle looks basically like that. We need to find out what this radius right here is, what that distance is. And we're going to use basically Pythagorean theorem or distance formula or whatever you call it to solve for it. So we have x minus h squared plus y minus k squared equals r squared. 1 minus 3 is -2. -2 squared is 4. -1 minus 6 is -7. -7 squared is 49. So r squared becomes 53. Now the radius would be the square root of 53. So this length right here, the square root of 53. We don't really need the square root of 53 though. We really need what r squared is. They want us to write the equation, and the equation uses r squared as we do it. So our final equation is any x, any point on the circle in the x direction, minus 3 squared plus any y point paired with your x on the circle, minus 6 squared, equals r squared, which is 53. They do not ask us to graph it. However, I think I just kind of did a graph like that. Okay, here's another one. Let's go and find the equation for this one. This might be good to graph as we go. So this is -2, 1 is your center, and this is tangent to the y-axis. So there's my y-axis, there's my x-axis. If I had a graph that went -2 over and 1 up as my center, and it was tangent to the y-axis, remember your geometry, a line tangent to a circle means that it touches it at one point. And watch as I go ahead, focus on this y-axis right here. There's only one way that I can make it touch at one point, and that is if it touches right, like that right there. That's the only way it's going to touch at one point. If I keep going down, it's not touching at any points. If I go over, it's touching at, look at that, 2 points. 1 and 2 right there. So you can see that as I grow, it keeps touching at 2 points. 1 point is only like that, and the only way it touches at 1 point is if the radius draws, I guess, if it draws perpendicularly to the tangent line. So notice how my radius here, as it goes out, it just draws outward like so. It must go straight out like that. And that would be the radius. It's perpendicular to this line right here. And if that's so, then my radius must be 1, 2. My r is 2. And that's the only way that this can happen if it was tangent to the y-axis with the circle. So what we know is our center, hk. We know our radius of 2, and r squared then must be 4. So our equation will be x minus -2, which is x plus 2 squared, plus y minus 1 squared. That equals 4. And that's my equation. That line. And the graph helped. We got a good visual that way. Okay, let's do a couple more. Let's graph this one, and then we'll find the equation of this one, and I think that'll be it on circles. So this x squared is also x minus 0 squared, if that helps you determine what your center is. And this should be y minus, -2 quantity squared, and this is 5 squared. Maybe you dig that stuff out. It might help you find your center of 0, -2, and your radius of 5. So as I do that, let's go and plot those. Here's the center, 0, -2. My radius is 5. I can go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Notice how I'm only going north, south, east, and west. It's very hard to count diagonally for these things in 5. It's not like I go 1, 2, 3, 4, 5. That would make me a square. I'm not going for that. And you only have a pencil to do this stuff with. Lucky me, I have a little bit more than that to do this with you. So I'm going to go ahead and graph that by going out that way. And these should land on here pretty appropriately if I did it right. And there's my circle once I found out that information. This one here, we have to find out the radius. It might also help to find the center. So pick any point in the north, south, east, west direction. That'll help. If I go from here, I'll go 1, 2, 3, 4, 5, 6, 7, 8 across is my diameter. So my radius is 4, which means my center is 4 away from any of those points. Same with this way, 4 away, 4 away. So my R is 4. My center, my center is 2, 0. So an R is 4. So let's go and write the equation of this one. This one will be x minus 2 quantity squared plus y minus 0 quantity squared is just y squared, and 4 squared is 16. There's my equation of that guy there. So as you can tell, when we do all these, I still have one more to go, but when we do all these, notice we either go from the circle, from the equation to some information to the circle, or we go from the circle to some information to the equation. Obviously, the information is the in-between point that you might want to write down. And if you have information, you can either write the equation or graph the circle immediately. So that's kind of nice stuff. So let's do this last one here. They do give us information, but sometimes it helps to graph it to get the actual information that we need. We need to find the equation of a line tangent to these lines here, and the center is in the first quadrant. So if I do a graph here. Give me a sec. If I do a graph, that might help me figure out, because remember we talked about tangent here. We have x equals negative 3. Let's go and do some lines. Go 1, 2, 3, 4, 5. Negative 3, and you find the x-axis. I think it's supposed to say the y-axis. Well, it says x-axis. Anyway, tangent to the lines x equals negative 3, x equals 5, and the y-axis. So let's do some of those lines there. Make them all dashed and whatnot and colored. We'll do happy red. Here is x equals negative 3. Here's x equals 5. Here's the y-axis right there. So our circle has to be tangent to all of these, which means it can only touch once at those places, which means your circle's rim basically, I don't know if I'll get this right the first time, your circle's rim basically has to look like that. It needs to touch at those places only once. So the only way that's going to happen is if your center is right in between these two guys, like if I can draw a diameter through there, which means my diameter goes through my center somewhere, wherever that is. Which means I need to figure out what the diameter is across here. That'll help me find my radius. So my distance between negative 3 and 5 is 8. So if my diameter is 8, whoops, guinea piggy. So if my diameter across there is 8, then my radius is 4. That also means this is 4, etc. Now to find the center, from negative 3, this goes negative 2, negative 1, 0, 1. So my x value is 1, my y value is 4. It's the only way it can be tangent to the y-axis. Now the other piece of information was they said that the center's in the first quadrant. Notice how my center's up there? Another circle that I could have done was draw one down here. This would have made this tangent to everything. This would have been another unique circle I could have made right there. The only difference is this tangent, this center, is in the fourth quadrant. That's not what they wanted. They wanted one in the first quadrant up here. So your equation, radius is 4, would be x minus 1 squared plus y minus 4 squared equals 16. There's your answer. Yeah, let's go ahead and talk about parabolas here. Parabolas, the locus of points that are equidistant from a single point and a line. Now that single point's called a focus. It's this guy right here. I'll try and make use of this graph as I want to write parabola here. There's my focus, and the line is called the directrix. Now, the focus and the directrix, the closest points of them, the focus is just one point, but the closest point of this directrix is equidistant from the vertex of the parabola, as is the focus. So these distances here actually are denoted c. That would be the length. This is c units that way, this is c units that way. Maybe you can call this negative c if it helps you find direction. But these are both c. All right. As I keep moving on, any point on the parabola, doesn't matter which one it is. Let's say we have this xy even. Any point there, if I draw a line from focus to xy, and I draw a line perpendicularly from that point to my directrix right there, these lines will be congruent, those segments right there. Same with these ones way out here. If I do another point xy way up here, another new point, the line from my focus to that point on the parabola will be congruent to the point, to the distance from the point of my parabola to directly down to the directrix. So those are congruent as well. And that's the relationship that a parabola has, and that comes into play with its stretch factor. The more that the stretch factor, the greater that the stretch factor is, if I made a parabola like this, the greater that the stretch factor is, the closer that the focus and directrix will be to each other. The narrower, like the more that my parabola is like this, the farther away focus and directrix will be to each other. But they still have that same relationship there. Focus is always inside of the parabola, meaning if it's faced this way, it'll be like that. If my parabola is facing this way, focus would be on this side, directrix on that side. Okay? And parabolas can also go left and right, they just won't be functions. So if my parabola is like this, there will be focus and directrix, and same with the other way. If it went this way, it would be focus and directrix. And they have that same relationship as we go along. We proved in class that A equals 1 over the quantity 4C, and also, conversely, C equals the quantity 1 over the quantity 4 times A. And these are two standard equations for parabolas here with a stretch factor of A. These ones go this way and that way, by the way, when x equals ay squared. We'll go ahead and do a few of these graphs as we go along. And we're going to start doing some shifty graphs. I'll even do it on the video to help you out. Okay, x equals negative 1/24 y squared. This is an example of this kind of equation right here. So our stretch factor is negative 1 over 24. I am not going to spend a lot of time doing the actual graphy graph of how that should look. I'll just go ahead. In fact, do I have a bow shape here? I do. I want to see if I can figure out a way to, maybe the parabola looks like that, right? Maybe there's negative 1 over 24, or maybe not. I don't know. But the point is, it is at the origin. There's no shift. And it is going, oh, it's not going that way. It's going upside down, or it's going, oh, you know what? Maybe I can't make it sideways then. Okay. I'll go ahead and just do my own. So x equals means our graph should be going that way. Okay, so negative 1 over 24 means a very, very shallowish looking graph. It should look very, that. See if I can do a good looking one. Very hard on this to make it happen. Alright, so maybe it looks like that, and that's negative 1 over 24 y squared, and it does cross at the origin there. So what we have to do is find the focus and directrix, and remember, the focus is just that one point that's equidistant from point directrix. The way to find it is figure out what C is. Now to figure out what C is, we have to know what A is, and we do. That's negative 1 over 24. So C is 1 over 4 times negative 1 over 24. Negative 1 over 24 is, negative 4 over 24 is negative 1 over 6. So C is 1 over negative 1/6, which is negative 6. So when I find my negative 6 value, basically I'm just going to use that distance from my vertex, right? The C is the units away from the vertex of the parabola. Now, if you do this right, this negative should emphasize the fact that it's also going in the negative direction of whatever way your vertex is, or whatever way your parabola is facing. So when I go negative 6 for my my focus, and go 1, 2, 3, 4, 5, 6, it should always be inside the parabola. There's my point F. My directrix should be on the other side, 1, 2, 3, 4, 5, 6, and the directrix will actually be a line that will look, let's say, like that. And that line represents D. Now, my focus point, I think we have to find these things, not just graph them. Let's find out what the focus and directrix are. The focus is at the point negative 6, 0. And the directrix, you can see over here, if you counted, would be at the line x equals 6. Okay? Now, once again, what all that means, because I'm not going to highlight this as much anymore after I keep moving on, this from here to here should be congruent, obviously. From here to here, if I graphed this right, these should be congruent. From here to here, these should be congruent as well. Obviously, they're probably not very much so, because I'm sure my graph is off. But if you did graph it right, these should all be congruent marks, and those are the makings of a parabola. Okay, negative y plus x squared equals 3. This might be nice to write it in one of these forms here. You know, the one that will make it most like what you're supposed to. So basically, solve for the variable, the single degree variable, this one right here. I'll go ahead and add y over. Well, I'd add a y over, I'd subtract 3 over. I'll get y equals x squared minus 3. That's basically what this equation is. Solve for it like a parabola. Write it in parabolic form so that your x squared is with the side of shifty stuff. And let's go ahead and graph this guy. Now, this vertex is off mark a little bit here. This goes down here. There's my vertex. And I can graph this one pretty well. This is up 1 over 1, up 2 over 4. Or, I'm sorry, over 1, up 1, over 2, up 4. Over 3, up 9. Like so. And I can reflect across my axis of symmetry and graph those 3 points there as well. And let's see if I can use that parabola line. That might work out pretty well. Or maybe not. Let's see. That's not bad, actually. That worked out all right. Let's pretend like that's our parabola right there. Okay, so there's our parabola. And go ahead and find the focus and directrix of this guy right here. Now, the stretch factor here, A, was 1. So as we go ahead and find out C, the distance from our focus to our vertex, and our directrix to our vertex, that would be 1 over 4A. That should be a 4. 1 over 4A, which is 1/4. So my C value this time is 1/4, which means I'm going to go up, in this case, 1/4 from my vertex to figure out what my where my focus is. So C is 1/4. There, right there is my focus. 1/4 up from there. That's F. My directrix will be 1/4 down from there. So my directrix goes right about there. Should have made it dotted. But there's my directrix line right there. And same thing about congruency. I go up here, down there, congruent. Over here, down here, congruent. Congruent, congruent, congruent. Focus directrix. So my focus is at the point. You have to go 1/4 up from the vertex negative, or 0, negative 3. So this is going to be at 0, negative 2.75, or negative 2 3/4. That's my focus point. My directrix line is the line y equals negative 3.25. I went a quarter down from negative 3, and there's my directrix line right there. So there's that information with that graph. Okay, let's see how much more we have. We have a few more, so I'm going to speed it up a little bit. Write an equation of a parabola with vertex t at the origin. I think that's just for these two guys, so I'm going to separate that one. So if your vertex is at the origin, these might be it might be helpful to draw these. Because when you draw it, 1, 2, 3, if you do negative 3 as your focus here, and your vertex is at the origin, you have to think about what this graph should be looking like. If the focus is always inside the parabola, then that means that your parabola must be going downward. If this is your vertex, it must be doing something like that. Which also means, that should hint to you, this is not only a y equals equation, but your A should also be negative. So this is maybe clues of what you should be doing as you're moving on through this. And it does help to just draw, you don't have to draw a perfect graph. Just give yourself something to work with there. Now, you do have a focus at 0, negative 3 there. So your C value then must be 3. I mean, in this case, I'm going to use negative 3 and just say that I'm going down from there because I know that I need a negative A value in the end. My directrix should therefore also be 3 up from here. I don't think that's necessarily important, but that's y equals 3 as the directrix. We need to find the equation of this, really, though. So we need to find the stretch factor. We need to find A. So we know what C is. negative 3. So A is 1 over 4c, 1 over 4 times negative 3, which becomes negative 1/12. And your vertex is at the origin, so there's no shift. We already know that. So your equation is y equals negative 1/12. Oops. Negative 1/12 x squared. There's my equation of that guy there. Okay, this one has a directrix at x equals 5. So, and once again, our vertex is at the origin for this. That's the first piece of information they clue us with. So as I go through here, I'm going to go ahead and draw you a directrix. Let's say this here is x equals 5. Okay, vertex, as we know, is at the origin. There's our v. So, once again, we're referring to if directrix is outside of the parabola, you can also think about, okay, well, this is 5 away here, which means our focus must be right over here at the point negative 5, 0, if the directrix is at x equals 5, which means our c here, in this case, is negative 5 as we go from vertex to there, so our graph should be going this way. So as our graph is going to the left, you should know not only is it an x equals a y squared equation, but once again, your stretch factor should be negative. And our c is negative 5. So let's solve for a, and we can write the equation. Once again, there's no shift as we go through. So this is a equals 1 over 4 times negative 5, which is negative 1 over 20. And if you use c as positive 5 and plug that in, you get positive 1 over 20. That's fine. Just make sure in your equation you recognize this should be a negative parabola as you go through. Much the same as you should know that this is an x equals equation. So this should be x equals negative 1 over 20 y squared. There is no other shift. That's all you have to it. Okay, and the last one, this one is not at the origin, at least not to my knowledge. You have a focus here at 2, 1 and a directrix at y equals 5. So let's go and graph that just to get the visual, to get the perception of what we're looking at here. So we have axes there. We have a focus at 2, 1. Right there. We have y equals 5, 2, 3, 4, 5 for our directrix. So we have two pieces of information. We still need to find the vertex here. We still need to get a shift going. We need to find out which way it's going, all that stuff. Okay, so we got focus and directrix. Now, if you think about what we talked about here in the very top, in the beginning, focus and directrix have some distance away called c in both directions, which means this total distance, now remember, that was the closest point to the directrix there. So my closest point to directrix will be right, like up, down, left, or right from it. Like, so in this case, there's 2c, right? If this is c and this is c, focus directions, this whole distance is 2c, which means c is going to be half this length, which means we can take c to find out what that vertex point is. Obviously, you can probably figure it out from there. So let me tell you some of it right now. There's my focus, there's my directrix. C equals negative 2, because we're going downward, because your parabola should be opening up that way. Right there. So my c here, this distance is negative 2. Oops. Your vertex is positive 2, positive 3. That'll help when it comes to a shift. Now we got to find out the stretch factor by using c as negative 2. So I have a equals 1 over 4 times negative 2, which is negative 1/8. To write this equation, though, now this is going to be y equals ax squared. But to write this equation, I really do need to use vertex form this time. I know that my vertex is in a different place. So I'm really going to be using y equals a times x minus h squared plus k. So my equation will be y equals negative 1/8 times x minus, what was it, 2? X minus 2, quantity squared, plus 3. As you saw where my vertex was right there. So that's my equation, knowing that information there. I needed to know the shift and work the rest of the way through as I went. Now remember, these were just parent graphs. These were just standard equations. We are going to do some shifting. The next slide will show that. We haven't really learned it. We'll be learning it more on Tuesday. But this is important to get the general start of which way it should be facing. And you need to find your stretch factor. All right, so let's do these last two here. Let's graph. I guess they're just asking you to graph these. They're not asking you to find. Oh, yeah, they are. Okay, focus and directrix. Let's graph them, find focus and directrix. Now, this form here is not unlike our normal form y equals a times x minus h squared plus k. The only difference is you can see in this one, they decided to subtract k over. So this looks like y minus k equals a times x minus h quantity squared. And that makes it look a little bit more like your circle form, if you remember going back a little bit here. Our circle form has that y minus k together with x minus h. You still know how the shift works. If they're paired together like that, then that means your center, your vertex in this case, is still at h comma k. So you can rewrite this if you want. I'll make it y equals negative 1/8 times x minus 4 quantity squared minus 5 if you subtract 5 over. Because then you know your vertex is at 4, negative 5. Maybe it helps that way instead of the other way. So as I graph this, let's go and do that. 1, 2, 3, 4. 1, 2, 3, 4, 5. There's the vertex. The shift, the stretch factor stuff, negative 1/8. As I go over 1, I'll go down 1/8. That doesn't help much. As I go over 2, I'll go down, I guess, 1/2. I go over 4, I'd go down 1, let's see, 3, 9, 4, 16. 16 over 8 is negative 2, so I'll go to negative 2 there. So I'm going to get it a little perfect if I can. Negative 8, 1/8, 1/2, 16. Using stretch factor, 1, 1, 2, 4, 3, 9, 4, 16. That's important. So there's my graph. There's the look. Close enough. Now, we have to find focus and directrix. Focus, we have to find the point, not just the C value, but to do that we need C. To use C, we have to use A. Our A is negative 1/8. So our C value is 1 over 4 times negative 1/8, 1 over 4A. So that's 1 over negative 1/2, which is negative 2. So if my C value is negative 2, and my focus is supposed to be down this way inside the parabola, I'm going to go negative 2 for my vertex to find the focus point itself. So I can go down 1, 2. There's my focus point, which is at 4, comma, 1, 2, 3, 4, 5, negative 7. There's my focus point. My directrix will be 2 up from there, 1, 2, and that line. So that line is y equals negative 3. There's my directrix. There we go. I can zoom out a little bit so I get this all in one thing. Where's view? View, zoom. Let's do entire page. There we go. That gives you a little more. I think you were too claustrophobic there. Last problem. This one would help. Now it's not a circle, right? We're not going to complete the square with this y value. This would help if we wrote this in vertex form, meaning it looks like this is another y equals equation because we have an x squared here. So I'm going to move, I'm going to first complete the square. That might help out. I'll get x squared minus 6x plus 9 plus 4y. I'm going to move the 13 over now. Negative 13 plus 9 again. I need to add that 9. So now I don't really have much room here. I'm going to write it down here. I have x minus 3 quantity squared plus 4y equals negative 4. Now as I start to solve for y, I'll move that x minus 3 squared over. I'll get 4y equals negative quantity x minus 3 quantity squared minus 4. And divide by 4, I'll get y equals negative 1/4. That's negative 1/4 times x minus 3 quantity squared minus 1. So there's vertex form of that. It helped by completing the square to write it in vertex form. I suppose you could have written it in standard form, but that's not going to help me for anything, right? I need to find the vertex anyway. So we have vertex form there, which means we have a vertex. Our vertex is 3, negative 1. So I go over 3, down 1. There's my vertex point. Our stretch factor is negative 1/4. I'll go and zoom in one more time. To do this, our stretch factor, what was it, negative 1/4? Over 1, down 1/4. Over 2, down 1. Over 4, down 4. 1, 2, 3, 4. Got to practice your stretch factor stuff a little bit. You're going to be quizzed on Friday, by the way, as we do this. So there's my parabola. Sure. All right, focus in directrix. We have an a value of -1/4. Let's use this room, the little room I have. So our c value is 1/4 times -1/4, which is -1. Total, it's -1. So my focus point is 1 down from my vertex right there. That focus point is 3, -2. The directrix will be 1 up from there, which is that line there, which is, of course, the line y equals 0. I'll go and zoom out. I think this was the last thing we were looking at. And I know this was far more than 20 minutes. I do apologize. I think all the information was important there. So there's the graph. And once again, focus, directrix. There's a line to the point. Boom, congruent, all that jazz. All right, so that's what you got. That was a wrap-up of the last week of what we've done, plus the shifting. We're going to do a little bit of that on Tuesday. So I hope that was good for you and that you learned a few more things there, wrapped it up. And so we get to check off all that stuff that we did. Woohoo! I'll see you.